We will continue with practicing questions from trigonometry. Paper is 14 and paper is a bit larger also. It's possible to do it in two separate parts, but anyway we will see how we are going, and if necessary in two separate parts, in two separate sessions, we will do it. If we can do it everything at once, it will be even much better. Anyway, the biggest part in trigonometry, of course, is solving trigonometric equations, and really you have to have full confidence in solving trigonometric equations. We will start with question 1. There are probably 10, 12 different trigonometric equations, and after this exercise, probably all of you will be quite confident what to do when there is one trigonometric equation to solve. Anyway, question under A. So we are solving question 1, and A is square root 2 sine x on 3 equal 1, and x is between 9 pi and 0. We said that the domain that is given for that equation is actually part of the question, and we can't solve question successfully if we don't consider domain. So, adjusting this equation a bit, we will have sine x on 3 equal 1 on root 2. So simply dividing equation by root 2 to get the simplest possible equation. And we said we always should start with this number in unit circle. For sine function, value is 1 on root 2, that is somewhere here, 1 on root 2, and two possible angles for our solutions are this angle and this angle here. Of course, we have to recognize 1 on root 2 from a table of exact values, and that giving us angle of pi on 4. So this angle is pi on 4, and the other possible solution will be this pi on 4, then another pi on 4 is 2 pi on 4, pi on 2, and we have another pi on 4, it's 3 pi on 4. So this angle is 3 pi on 4. Now we have to stop here, because we have to check domain, but also we have to check the angle. Angle is not x, angle is x on 3. So we have to adjust domain for this angle. Simply by dividing x on 3, we have to also divide this side by 3, so it will be 3 pi, and here will be just 0, because when we divide 0 by 3, so we will get again 0. Anyway, now we have domain, and all what we need just to pick up our solution for x on 3 angle. And we can write x on 3 is equal, we are going in positive direction, in that way, first solution is angle pi on 4, second solution that giving us 1 on root 2 is 3 pi on 4, and if we continue, we can't reach that point from any other angle. We are up to 2 pi, but we need to go for 1 pi more. So we are going again around the circle, and again we have this as a solution. If angle pi on 4 by symmetry, this is 8 pi on 4, and another pi on 4 is 9 pi on 4. And we will continue. This is another solution. If this was 9 pi on 4, 10 pi on 4, 11 pi on 4. Of course, I am just counting how many pi's on 4, but you can simply, on pi on 4, if you add another 2 pi on 4, of course you will get 9 pi on 4. Or on 3 pi on 4, if you add another 2 pi, then you will get 11 pi on 4. But just simply to avoid working with fractions, it's not really necessary to calculate. Simply just use symmetry of your unit circle and account 1, 2, 3, 4, 5, 6, 7, and you will get these numbers without any problems. Of course, now we have to get just x. We will get x when we divide everything by 3, so it will be pi on 12, 3 pi on, when you multiply by 3, what I am doing here, when you multiply by 3, it will be 3 pi on 4, and then it will be 9 pi on 4, then it will be 27 pi on 4, and 33 pi on 4 will be all solutions to this equation. Question under B. Is to solve equation cos x plus 0.42 equal to 0, and for x 0 to 2 pi. Now, just little adjustments, this to move on the other side, and we have cos x equal minus 0.42. Unit circle. I'm getting a bit better with these circles. And starting with this number, to see where is that number in unit circle, cosine function, this axis, negative 0.42, roughly somewhere on the middle, a little bit closer to 0, so negative 0.42 is this point here. Now, two possible angles, two possible solutions are this one and this one. So this and that. Of course, 0.42 is not an exact value, so our solution for x then will be cos inverse of minus 0.42. And you have to use a calculator, and your calculator will give you, that is equal roughly 2 anyway, we will round off to 2 radians. Again, you have to be careful on calculator when you're reading this value. It could be also possible that calculator, depends how you set your calculator, will give you actually this angle here which is positive 0.42. But anyway, that's why I said, if your calculator is giving you as a solution of this, that is 2 radians, then you have to understand if 2 radians, that is around 115, 100, maybe less than 120 degrees, then definitely you are in this quadrant here. But if you get here, let's say, I don't know, 1 or things like that, a little bit smaller, then you are here. So this is important to understand message from your calculator, to understand a number that you are reading, and have a look in your circle, see in which quadrant you are. So this is the first solution. This is this angle. Here it's 2 radians, but the another angle is both. We have to use symmetry to find this angle here. How to use symmetry? Simply by symmetry of this, as this angle here is equal to that angle, then obviously this angle, which is 2 radians, will be the same as this angle here, which of course will be minus 2 radians. Then to get this angle here, obviously this angle and that angle are making 2 pi, making the full circle, and next solution then will be, I'll write x equal to, and next solution will be 2 pi, so you are going full circle up to 2 pi, and taking this angle here, which is 2 radians, so will be 2 pi minus 2, another solution. Anyway, we are in just domain 0 to 2 pi, there are only 2 possible solutions. So remember, unit circle, and you have to be ready to use unit circle. The other approach, especially mistakes in solving trigonometric equations, are happening on calculator. Because the another way to solve this equation or any other trigonometric equation is just to plot all this like a graph and see where intersection points graph has with x-axis. Everything is fine for as long as your window on your calculator is adjusted somehow to fit in this domain your function. But if your window can fit several cycles of this function, then if you start taking each x-intercepts, then you will get more solutions here. And in that case, those solutions doesn't have any sense because they are not solution to that equation because you have this domain here. Of course, you can do it correctly, but you have to always, when you're using calculator for solving equations, always you have to enter this domain here to have graph on your calculator just in that domain, nothing else. So here you have to be careful because the most common mistakes in solving trigonometric equation happen when people are using calculator but they don't enter correct domain, and then of course calculator sometimes giving just one cycle maybe, but inside the domain this function may have 3 cycles, so you are missing another 4 solutions. You have to be careful with that. Next question is question under C. sine 5 pi x equal root 3 cos 5 pi x, and domain for x is 0 and 1. We already discussed on our last session. We already discussed this domain when there are no pi here. But anyway, we have pi here, so everything is perfectly fine. We can adjust domain and to know exactly how many times to go around circle, where to stop, where to start, and things like that. But this equation is a bit different than first two. The difference, again, we have sine and cosine, and if you remember, this equation we can divide by cosine 5 pi on x, because cosine 5 pi on x in this equation can't be equal to 0, and we can divide by cos 5 pi x. Then here we will have sine 5 pi on x divided by cos 5 pi on x, that is tangent 5 pi on x. You have to memorize those few formulas in trigonometry, and when you divide this by that, you will cancel them and you will get just root 3. So we have the simplest form of our equation. Then to see what's happening, unit circle, tangent, we have to make this line, and root 3, 1 is here, and root 3 is 1.7 something, then it's a bit higher than 1, somewhere here, and we have that angle, and another possible solution can be this angle here. I am saying possible solution because in this stage still we don't know how many solutions we will have and what they should be. Should be both of them, should be some more, should be just this one, or maybe just this one, or maybe no solutions at all. Depends everything of this domain. Now we have to adjust domain. So we have this situation here, and we have 5 pi times bigger angle than this one here. So we need 5 pi on both sides to increase. So 5 pi x, then 1 multiply 5 pi will be 5 pi, but on the other side nothing is changing as we have 0, so here will be 0. Now this is domain for this angle, for 5 pi x. That means this small angle here is 5 pi x, and we can recognize root 3 from table of exact values, and for tangent function it will give us angle pi on 3. So first solution will be for 5 pi x will be pi on 3. The second solution, so this is pi on 3. The second solution will be up to here. We have 3 pi's on 3, and one more will be 4 pi on 3, and it will be our second solution. up to 2 pi are no more solutions, but we have to go up to 5 pi. So another one, yes, it is a solution. Here is 2 pi, we have 6 pi on 3, and one more, 7 pi on 3. Now here we have 9 pi on 3, and one more will be 10 pi on 3. Nothing happening up to this point because there are no solutions, and then as we are second time going around the circle, so here we reach 4 pi, or in pi on 3 will be 12 pi on 3. One more, because we are going up to 5 pi, will be 13 pi on 3, and 5 pi will be here. We can't reach next solution. These are all solutions. Now we have to divide everything by 5 pi, and then write solutions just like x equal. Then when you divide this by 5 pi, pi and pi cancel, you have 1 on 15, and similar for all other will be 4 on 15, then 7 on 15, then 10 on 15 you can cancel by 5, sorry, will be 2 on 3, then where are we here, then it will be 13 on 15. So this here still less than 1, and yeah, they are perfectly fine. X between 0 and 1, 1 on 15 very small, this one is almost close to 1, so everything is perfectly fine. Remember, this equation we can divide. Next question. I think next question we already did in previous session, if I remember well, and question under D better to skip because it's really, we had one very similar, maybe even the same question in previous session. You can practice at home, but really not necessary here, and better to move on something else. So we will go, let me check DE, yeah? We will go on question E, and question E is similar to previous one, sine 5x minus half cos 5x on 5x, just 5x, 5x equal 0, and x is 0 to 2 pi on 5. Now, again we have equation like one before that we did, previous one, sine and cosine. We already learned where only sine and cosine, then we can divide by cosine. then equation is sine 5x equal half cos 5x, and then we can divide this by cos 5x, don't divide by half. In that case you will get half on the other side, after that you have to move it on the other side, so wasting time. Then sine 5x divided by cosine 5x is tangent 5x equivalent cosine and cosine cut, and this is just half. Again, unit circle. And this number on that line, this is 1, this is 0, so half should be somewhere here, and that is one angle, but also another possible solution is this angle here. Domain given for x, our angle is 5x, we have to change domain, and here we have x smaller equal 2 pi on 5 greater equal 0, but 5x is 5 times more, 5 times this will be just 2 pi, and on the other side 0. So we have now domain for 5x, because that is our angle, and this number here is just for that angle anyway, value for that angle. And obviously it will be two solutions, because from 0 to 2 pi, and both of those angles will be solutions. So we can write 5x then equal half is exact value for sine function and cosine function, but half is not exact value for tangent function, so this we again have to use calculator. 5x equal then tangent of 5x, and on calculator I should have it here. The angle is 0.46, not 5x, sorry, half, and the angle is 0.46 radians. Is this okay? Let's check it. We are talking about this angle. 1 radian is 57 degrees something, 57.23 something. 0.46 is roughly half of that, so roughly less than 30 degrees. We are there, so this is correct. And another one solution for 5x then will be this angle here, but this angle and that angle, they are the same, because one line, another line crossing, and those two angles the same in geometry. And we have from this point up to there just pi, and plus this angle, that is that angle, so next solution will be pi plus 0.46. I am not writing all those decimal numbers, but anyway, if you are on a test or on exam, then definitely you have to calculate this 3.14 on calculator plus 0.46, and whatever you get, that should be your answer. Don't leave it just like this. And again, one equation, new question. f, the equation is sine 5x cos 5x minus a half cos 5x equal 0. And the domain for this equation is minus pi on 2, 2 pi on 5. Similar equation like last two that we did, but anyway, I see there is some difference because here we have product of those two and cosine here. And if you remember from last session, we said that this equation we can't divide by cos 5x. If you move this on the other side to divide to get tangent. Why we can't? Because cos 5x in this equation is equal to 0. Because 0 minus 0 multiplied something is 0. 0 multiplied 0 is equal to 0. So cos 5x is really equal to 0 and we can't divide. So we learned on last session to factorize actually this equation and to apply non-factor law. Taking common factor cos 5x and then in brackets we will have sine 5x minus half equal to 0. And now applying non-factor law, we have two factors, we are forming two equations and we are solving both of them, and solutions of both equations will be solutions to our equation. So cos 5x equal to 0 or sine 5x minus half equal to 0, we can write straight sine 5x equal half. And now simply solving each of those equations. I don't know if you need a unit circle for this equation, but anyway, I will make it. 0 on this line is here, and angle that will give us this value is one is pi on 2 and another angle is 3 pi on 2. So we can write solutions, but before we write solutions, don't forget x is this, our angle is 5x. So we have to adjust this domain, and this we can write like x smaller equal 2 pi on 5 greater equal minus pi on 2. But our angle is 5x. Then 5x smaller equal this to multiply by 5, cancel 5 and 5, and it's 2 pi. On the other side, we have to multiply minus pi on 2 by 5, and it will be minus 5 pi on 2. Now this will be domain for 5x angle. To make it easier, I recommend this line 0 and 2 pi, and on the other side 5 pi on 2, that is 2 pi and 1 pi on 2 more, somewhere here, minus 5 pi on 2, a little bit longer than this. And now we can start getting our solutions. So 5x, and starting from 0, going in positive direction up to 2 pi to pick up all solutions here. So starting from here, finish there, and we have two solutions. First solution, we set pi on 2, and second solution is 3 pi on 2. Of course, now we have to go in negative direction, because we have this part of domain, and in negative direction will be, this is the first solution, that is negative pi on 2, and this is another solution, negative 3 pi on 2, and we have to stop there, wait, negative 5 pi on 2, okay, we have to continue and to stop here. But one interesting thing, this is one more solution, because we have this square bracket. If this bracket was like a round bracket, that means that point not included in domain, and we can't state this as a solution. But in this case, yes, equal, so we have to state another solution, minus 5 pi on 2. So all those are solutions to this equation within that domain. Of course, just x, so divide by 5, and anyway, pi on 10, 3 pi on 10 minus pi on 10 minus 3 pi on 10, and minus, when you divide by 5, cancel 5 and 5, and minus pi on 2. See, minus 5 on 2, point included, and we have that point as a solution here. Now, to solve this equation, I will make a circle here. And we have half for sine function on this axis, half somewhere here, possible two angles, this one and that one. Exact value is angle pi on 6. The other one less than 6 pi on 6 is 5 pi on 6. And exactly the same what we did here, and now we have to go in the same domain, because this is from the same equation, and to pick up all solutions. Then we can write 5x equal, and going from 0 to 2 pi, we have two solutions, pi on 6 and 5 pi on 6. Stopping at 2 pi, no more solutions. Now, the way in negative direction, and nothing is happening here up to there. This is negative 6 pi on 6, and one more negative is negative 7 pi on 6. Then this is also solution, and here negative 12 pi on 6, one less negative is negative 11 pi on 6. We are up to 2 pi. We have to look at the domain. We have to stop here, and even if we continue to come to there, there is no any solution. So this equation will have those solutions. Of course, again, we have to get solutions just for x. So x equal, when you divide by 5, will be pi on 30, then will be pi on 6, then will be negative 7 pi on 30, and then negative 11 pi on 30. So all this and this here are solutions to this equation. So we have here 5 and 4, it's 9 solutions to that equation. Of course, if this domain was different, then it would be different number of solutions. So just I am trying to focus, I'm trying to bring your attention to domain, because there are happening the most common mistakes. That was question number F. Now we are going question number G. And question G, we have 1 minus cos x equal to sine squared x, and domain 0 to 2 pi. Again, one equation that is useless to divide, especially we have this one here, so nothing we can do really with division. And keep in mind, always when you have power 2, then we are talking about quadratic equation. So we can't still make any substitution here to make polynomial quadratic equation, as we have different functions, cosine x and sine x, different terms actually. So we have to use identity, sine squared x plus cos squared x equal 1, to change one of those two in terms of the other one, and then to have all terms with the same function. So which one to change? Always this quadratic function change, otherwise this will give you a square root, so it will get much more complex. Sometimes even can bring you to the wrong solutions anyway. Then sine squared x equal 1 minus cos squared x, and replace this sine squared x by 1 minus cos squared x. Then we have 1 minus cos x equal to multiply 1 minus cos squared x. And now it's quite clear that we are talking about a quadratic equation. We have the same cos, and simply to expand this and to rearrange the equation. 1 minus cos x equal to minus 2 cos squared x. Bring everything on one side, and then we have 2 cos squared x minus cos x, and plus 1, this on the other side will be minus 1, and minus 1 equal to 0, and we have one quadratic equation. Anyway, you can use quadratic formula if you like. in any case, you can write cos x equals 0, u, and then replace it here, but maybe wasting time. I mean, we know what we are looking. We are looking for cos x, and straight away you can write cos x equal, and write quadratic formula. You have coefficients 2, -1, and everything is fine. So here will be 1 plus square root 1 minus, but because of this minus will be plus, 4 times 2, 8 times 1 is 8, divided by 2a, so divided by 4. And cos x then equal, this is 9, square root from 9 is 3, 1 plus 3 is 4, divided by 4 is 1, or cos x equal, now 1 minus 3 is minus 2, minus 2 divided by 4 is minus half. And straight away we have those two equations to solve. And cos x equal 1, we are talking about that point. Domain is 0 to 2 pi for x. Everything is fine, we don't need to adjust domain. And here we have one solution only. Actually not one, we have two solutions, because again 2 pi included and 0 included, and x will be 0 and 2 pi. For example, let's say here, if those two brackets were round brackets, then what? Those two solutions are not solutions actually. So we have to exclude them from solutions, and we will state this equation doesn't have any solution. In this case, both of them are solutions. And now to move on this equation, minus half for cosine is here. Two possible solutions, this one and that one. Half is an exact, number from a table of exact value, and in our first quadrant for cosine, that will be here, and the angle is 60 degrees or pi on 3. So this angle then will be 2 pi on 3, and this will be 4 pi on 3. The same domain, and all what we need just to state for this that x equal 2 pi on 3 and 4 pi on 3, and all together are solutions to this quadratic equation. So remember, when we have quadratic equation, nothing else to think. First thing to think actually, think about this trigonometric identity, and in most cases that identity works perfectly fine. Okay, what is the next question? Next question is hedge. We have many questions. So our next question on the hedge is 2 sin squared x plus 1 equal minus 5 cos x, and x is 3 pi to 0. Again, it's quite obvious. Now we are confident enough that we have a quadratic equation. We have to change sine squared x in terms of cos squared x, and we can write straight away 1 minus cos squared x plus 1 equal minus, is this 5? Yeah, minus 5 cos x. Expand 2 minus 2 cos squared x plus 1 equal minus 5 cos x. Rearrange it, or if you like you can bring this on the other side to make first term positive. Then will be 2 cos squared x minus 5 cos x, and 2 and 1 is 3, on the other side is minus 3 equal to 0. Is that correct? Yeah, it is. And then quadratic equation, then cos x equal, quadratic formula will be 5 plus or minus square root 25 minus, but because of this minus will be plus, 2 times 4 is 8, 8 times 3 is 24, divided by 4. Then cos x equal, this is 49, square root from 49 is 7, 5 plus 7 is 12, 12 divided by 4 is 3, or cos x equal 5 minus 7 is minus 2, minus 2 divided by 4 is minus half. And now to solve. Yes, no solution. Not no solutions, but basically we can't take this number as a solution for this equation, as cos x can't be greater than 1. So simply this we should reject. And all what we need to solve this equation. Of course, we just in previous question we were solving this equation. There only would be a difference because up to 3 pi, so it will be one more solution that we had in question before. Now we have one interesting equation